Hi everyone, I'm Shobana, working as an assistant professor in S.A.E. Engineering College in C.H.E. department. I'm here to discuss some of the GATE questions related to programming in C. So programming in C is a high-level language. Generally, the programming language is classified into machine language, assembly language, high-level language. Machine language will have zeros and ones. We cannot write coding using zeros and ones. It will be difficult for us. High-level language is more related to English. So C is a high-level language. It will be easy for us to write. Assembly language is an in-between language. For a single line, for example, if you want to add two numbers, a plus b or 5 plus 2, for that itself in assembly language you have to use 3-line coding. It will be quite difficult for us. So this is a general structure of C. First one is command line. So this is just for our understanding. For our understanding, we can write any statements that will come under command line. It will start by /. Then preprocessor directives. If you are using any predefined function, we have to include the library files. Hash include, all those will come under preprocessor directives. Hash define is used to define a constant. Global variables means if you declare any variables, that will be common to all the functions, for main function as well as for any kind of function, that we call as global variables. The main function, here where the execution starts. So this part is the most important thing. So inside that function you can declare any variables, you can write any statement based on your operations. Then user defined function, if you need, you can write user defined functions. So tokens, C tokens, we have operators, keywords, constant, string, special symbols, identifiers. Keyword is nothing but some of the reserved words. So in C language, we have certain words which have already which have some meanings. So for that purpose, we will be using it. We cannot use that as identifiers. Identifiers is a name given by us for variables, for functions. I can give my own name. It has certain rules. We can make use of symbols, underscore symbols, numbers, and alphabets. Operators is any kind of mathematical operators, and operator, everything comes under operators. We can make use of those. Constant, any number, and my name, everything falls under this constant. String is my name, will fall under a string constant. In strings, you have to enclose it within a double quotes. Then any kind of special symbols like open parenthesis, close parenthesis, semicolon, ampersand symbol, everything falls under this special symbols. So let's see this question. The number of tokens in the following printf statement. So this printf is a keyword. It is already defined in a C language. Then this open parenthesis is one of the token. Printf is one of the token. So this is enclosed within a double quotes. So this is a string token. Then comma, we have two commas, I, then ampersand symbol, again I, close parenthesis, semicolon. So we will have 10 tokens. So data types. So we all have memory. In such a way, our computer also has memory, and it is defined by us. So we have to specify the size of the memory, and we have to give a name to a memory. So here, for example, if I want to store a earring, I need a small box. If I want to store a bangle, I need a larger box. So here in C, the memory is represented using bytes. So here for int will require 4 bytes in 64-bit computer, float requires 4 bytes, double requires 8 bytes, char require 1 byte. So each kind of things will require certain amount of bytes in memory. So generally it is classified into primary, derived, and user defined. So variables. So we have to give a name to the memory location. So for that I will be using an identifier. I can give my own name to the variables. It will be very difficult for us to remember the address of the memory. So I will be giving some name. So at first, whenever you write a program, you have to declare a variable. So based on that, a name will be given. If it is integer, in 64-bit computer, 4 bytes will be allocated. Then array is a collection of similar kind of data items. So if I want to declare a register number for 42 students, instead of declaring 42 variables using array, I will just declare only one variable, and here within the square bracket I will specify the size. So here all the data should be of same type. Either all should be of integer or all should be of float. and this is a single one-dimensional array, and this is a multi-dimensional two-dimensional array, and you can have multi-dimensional array also. So for two-dimensional array, you have to specify number of rows and number of columns. So functions, for example, I am developing a very big project, some kind of code gets repeated here and there again and again. So instead of writing it again and again, I can write it inside a function as a separate block. So whenever I need of that part, I will be just calling this function and making use of it. So function will have a declaration part, call part, and a definition part. In definition part, I have to write the coding. Whenever it is necessary, I will be calling the functions. If you want to pass the input, you have to specify it within an argument list. If you want to return the answer, you have to specify the return type. If you are going to return an integer type, you have to specify it as int. So pointer, from the name itself we can say that pointer is pointing to something. So it will be pointing to a variable. So general syntax is data type asterisk then your pointer name. It should hold the address of another variable. So A is having a value 10. This P is a pointer variable. I am assigning the address of A to the pointer variable P. So P is pointing to the variable A. The meaning is P holds the address of A. Indirectly it is pointing to the variable 10. So if I want to access the value 10 indirectly through this pointer, I have to use it as asterisk P. So let's see one of the example. Consider the following function implemented in C, void print xy. So here we have defined a function called print xy. I am passing two arguments, 1, 1. So it will reach this x and y. So x and y will have a value 1 and 1. So the x address is, I have considered the address of x is 1000, address of y is 500. So inside I have declared one pointer variable, ptr is a pointer variable, x, I am changing the value of x to 0, y equal to, ptr equal to ampersand x. So now ptr will be pointing to the variable x, then y equal to asterisk ptr means y equal to x. So I am changing the value of, I am assigning the value of x to y. So both will become 0. Then asterisk ptr equal to 1. So ptr is pointing to the variable x. So the value will be changed here. X value will become 1. So finally the output will be 1, 0. This is another one example. Here they have defined a function called f which has an integer and a short as an argument. So here they are asking which statement will come here to call the function. So let's first see the first example. First option f(s), asterisk s. So here the function first argument is integer, second one is short. So I has a value 100, short has a value 12. Short is nothing but an integer. Integer can be classified into short int or long int. Short int will require lesser number of bytes than int, and long int will require larger number of bytes than int. So here this p is pointing to the variable yes. P is a pointer variable of type short. It is pointing to the variable yes. Okay, here f(s), yes. So s is a short. So you cannot put this function call. Second, I(s). I is a integer, s is a short. Yes, it's correct. But here it is returning a value. But here our return type is void. So it will not match with the B option. Third option, C, F, I, asterisk S. So, okay, I is an integer. Then star S. S is not a pointer variable. It is a normal variable. So, this will not come. Last option, I, star P. So, star P means yes. So, F of I, S. So, that is the correct option. Then array of pointers. So, array can point to a pointer can point to an array. So while assigning the address of array, we should not make use of the ampersand symbol. So array can be represented in this way also by using pointer. So AR of 0 can be represented using AR of plus 0. AR of 1 location can be represented by using AR of plus 1. So we have different representations to represent the array using pointers. So another example, consider the given three C functions. We have three options. So which of the above three functions are likely to cause problem? So first one, int asterisk, so it is returning a address. The function name is G. We don't have any argument, so it is void. So x value is 10. You are returning the address of x. Yes, it's correct. Second option, here it is returning the address pointer. We are returning a pointer. Yes, it's correct. It will return the address. Third option, here we are using a malloc function, and here also we are returning a pointer variable. Here the issue is malloc can allocate space only during the runtime. So but all this process will take place during compile time, so it will cause an error. It will not know the address of the variable. So option P1 and P2 will be correct. So this is the next example. So f is a user defined function, and here we have main functions and passing the address of I and j. So I value is 0 and j value is 1. So P and Q will receive the address of I and j. Indirectly it is pointing to the variable I and j. So if you make any changes in this function, it will get affected. It will get reflected here also, because we have passed the address of the variable. So let's come here. PQ, the value will be 0, 1, P equal to Q. So we are making the pointer variable P to point to the variable J. So now P and Q both are pointing to the variable J. So star P equal to 2. So star P, now it is pointing to the variable J and changing the value to 2. So finally X value will be, I value will be 0 and J value will be 2. So fourth option. So this is the next example. The output of the following C program is, here we have declared an array and one pointer variable called asterisk IP. So we know array, so array always starts from 0th location. So ARR of 0 will be the first value. It goes on like this. Star IP equal to ARR plus 4. The meaning is ARR of 4. So ARR of 4 will be the first location of the pointer variable IP. So it is pointing to the value 5. So when you represent IP of 1, the meaning is the next location. So IP plus 1. So the value will be 6. Storage classes, we have 4 different kinds of storage classes: auto, register, static and external. So here the scope and the lifetime of these variables will differ. For auto is a basic one, the default one is auto. So if you declare a variable using auto keyword or int a, so the its scope will be within the block and its lifetime also will be within that block, not the entire program. Register, the storage will be done in a CPU register, so it will be faster. Again the scope and lifetime will be within the block only. Static, the value will be automatically initialized to 0. The scope will be within the block. So you can make use of the variable within that block, but the value persists throughout the program. So if your program have 5 functions, in all the functions this static variable will be displayed, but you can make use of it within that block only. The value exists in all the functions. So in external, the scope is also global. The lifetime is also global, so it will be visible throughout the program. So let's see one of the example. Here I have in INCR function, I have declared the count variable as static. I am increment the value by I and returning the value. Let's come to the main function. Here only the execution starts. I have declared 2 variables I and j. I have used a loop. So it starts from 0 and ends by 4. Now I am calling the INCR function by using this I value. So first the value will be 0. So 0 plus 0 will be 0. Again the j will receive a value 0. Again the loop will be incremented. I am again calling the function. So 0 plus 1, the value will be 1. So till when it executes till 4, the value will be 10. If it is not a static variable, again and again the count value will be initialized to 0. But here it is a static variable, so again and again it will not be initialized to 0. The value will persist. That's why we are getting the value 10. Otherwise we will be getting the value 4. So structure and union both are used to store a dissimilar data type. So I have one integer type and I have one floating point variable. So I can combine these two and put it in a structure. So both structure and union are similar. They are used to store the different kinds of data. The difference is in structure, for each variable a separate block of memory will be allocated, but here this union will share the memory space. So int require 4 bytes. For example, in 32-bit computer, int require 2 bytes, float require 4 bytes. The maximum size is 4. So only 4 blocks will be allocated, 4 bytes will be allocated. Both int and float will be using the same memory location, but here in this case a separate block of memory will be allocated. For integer 2 bytes, for float 4. So totally 6 bytes will be allocated. So that is the difference. So here assume that objects of type short, float, long occupy 2 bytes, 4 bytes and 8 bytes. So short require 2, for float 4, for long 8 bytes. So here we have used structure as well as union. So short S of 5, short requires 2 bytes, so it is an array, so 2 into 5, 10. Then we have used a union. Union has two variables, y and z. Y requires 4 bytes, long requires, z requires 8 bytes, so 8 is the largest one. So for this union, only 8 bytes will be allocated. So 10 plus 8 will be 18. So 18 bytes is the correct answer. Thank you.